Alright, Kodiak's just wanted to run through the calculations on the formula of a Hydrate Lab. And so what you need are the various masses that are measured in the video. So the first mass that you need is the mass of the evaporating dish. And the mass of the evaporating dish was 31.81 grams. Then the evaporating dish plus the hydrate. Evaporating dish plus the hydrate from the video was 59.34 grams. So then to find the mass of how much hydrate you have, of course all you need to do is subtract the mass of the dish from the mass of the dish plus the hydrate. So the mass of the hydrate is the difference between 59.34 and 31.81, which is 27.53 grams. That is the mass of the hydrate. Then, after heating the hydrate, you have the mass of the dish plus the anhydrous, the stuff that has been heated and lost all of the water, and the mass of the dish plus the anhydrous mass is 45.84 grams. And so then the anhydrous mass is going to be the difference between that and the evaporating dish. So 45.84 minus 31.81, that's grams and grams, and that gives us an anhydrous mass of 14.03 grams. Alright, so now we have some numbers to work with. We have the hydrated mass, that is the magnesium sulfate with the water. The hydrated mass is 27.53 grams, and we need to subtract from that the anhydrous mass, the 14.03 grams, because that's the mass of the magnesium sulfate without the water, and what we'll have is the mass of the water. So that's going to equal the mass of the water, which is 13.5 grams of water. So what do we do with those numbers? Well, we need to figure out how many moles of each that is. So 13.5 grams of water, and the other number that we have is the anhydrous mass, which the anhydrous mass is 14.03 grams. So you have 14.03 grams of the magnesium sulfate, MgSO4, with no water at all. So then, how do we figure out how many moles of each there is? You're going to have to take the formula and add up the mass numbers from your periodic table for each of those. So hydrogen is 1.008 grams per mole, and there are two hydrogens. And then oxygen is 15.999 grams per mole, and there's just one oxygen. And that gives you a mass of water. Grab my document camera here, or grab my calculator. So 1.008 times 2 is equal to 2.016 plus 15.999 is equal to 18.015. So 18.015 grams of water is equal to 1 mole of water. So to figure out how many moles of water were in the hydrated magnesium sulfate, we'll take 13.5 grams of water divided by 18.015 grams of water per mole of water. And so we will get 0.749 and 0.7493, so I'm just going to say 0.7, going to round that off to 5.75 moles of water. We need to do the same thing with the magnesium sulfate. So to figure out the molar mass of the magnesium sulfate, you have 1 magnesium, which is 24.305 grams per mole. You have 1 sulfur, which is 2.066 grams per mole, and then you have 4 oxygens. Oxygen was 15.999 times 4 oxygens. Find the total there, and when you do find the total there, it comes out to be 120.367 grams per mole. You have 14.03 grams of anhydrous magnesium sulfate from the experiment, divided by 120.367 grams per mole, and that will give us 14.03 divided by 120.367 is 0.1165, so 0.117 moles of magnesium sulfate. So now we need to find the ratio between moles of magnesium sulfate and moles of water. So in order to do that, we know that the ratio of water to magnesium sulfate is 0.75 to 0.117. So 0.75 divided by 0.117 is equal to 6.41. So 6.41, and that would be moles of H2O to MgSO4. Now, of course, you can't have 0.41 waters, but we are doing this experimentally, and the actual answer, the actual formula for the hydrate of magnesium sulfate, it's magnesium sulfate hepta, which is 7 hydrate. So we got pretty close. 6.41 isn't too far off, but remember, you can figure out how far off it is by calculating percent error. So percent error is going to be our experimental value, 6.41, minus our accepted value, 7, over our accepted value, which is 7, times 100. So when we do that math, we get negative 0.59, the difference between 6.41 and 7, and divided by 7. I'm running out of room here, but I think we'll still be able to see it. If I take 0.59 divided by 7, I get 0.0842, 428. So that as a percentage is 8.43%, and it would be negative because we were below the accepted value error, which for the methodology we used was not bad. So that's how you do the calculations for the formula of a Hydrate Lab. And if on a test or a quiz you were given similar data for a different salt from a simulated lab, then you'd be able to figure that out yourself as well. So until next time, thanks.